Okay, welcome back to McNabb Chemistry. Today we're going to have a look at the trends in chemical properties of group 7 elements. If you remember, the group 7 elements are also known as the halogens. Okay, the halogens then that we need to consider are fluorine, chlorine, bromine and iodine. So F2, Cl2, Br2 and I2. And we then need to go on and consider the oxidizing power of these halogens. Okay, so that's what we're looking at today. We're looking at the oxidizing power of these 4 different halogens. Okay, so we are looking to see which halogen is the strongest oxidizing agent, and remember, an oxidizing agent itself is reduced, so that's very, very important. So if we have an oxidizing agent, the oxidizing agent itself is reduced. Okay, so that means that the substance that's behaving as the oxidizing agent will be gaining electrons. Okay, so your strongest oxidizing agent is the species that can gain electrons most easily. Okay, so we are looking to see which of the following reactions takes place most easily. So when F2 gains 2 electrons, it forms 2 fluoride ions. Another way of writing this, just to show that the equation is gaining 1 electron, or the reactants in the equation are gaining 1 electron, is to write it as half F2 plus an electron goes to the F atom. Okay, then we're looking at Cl2 plus 2 electrons making 2Cl minus, Br2 plus 2 electrons forming 2Br minus, and I2 plus 2 electrons forming 2I minus. Okay, let's move that up there. Okay, so remember, we're looking to see which one of these is the strongest oxidizing agent, so i.e. which one of these can gain the electrons most easily. Okay, now to consider this, okay, you see here the next question then is, what do we need to consider when deciding which, okay, let's get that straight. So the next question is, what do we need to consider when deciding which is the strongest oxidizing agent? Right, this is really important now. We've got to consider 3 things. First of all, we need to consider the strength of the halogen-halogen covalent bond, so the Cl-Cl covalent bond, or the F-F covalent bond, or the Br-Br covalent bond. Okay, so we need to consider the strength of the XX bond breaking to form X in the gas phase. So if I take half X2 gas, it makes an X atom. Okay, X is the halogen. Okay, that's the first thing we need to consider, the strength of the XX bond. Right, the next thing that happens then, well, what happened to that X atom? Well, the X atom gained an electron, didn't it, to form X minus, the halide ion. Okay, so the next thing that we've got to consider is the affinity of an X atom for an electron, forming an X minus ion in the gas phase. Okay, and then finally we've got to consider the energy released when the X minus ion either goes into solution or enters into a crystal lattice. So when the X minus ion from the gas phase goes into solution, or when the X minus ion from the gas phase goes into the crystal lattice. Okay, so 3 things that we've got to consider when deciding which is the strongest oxidizing agent. The first thing is the strength of the bond in the halogen molecule. Okay, the second thing is, once we've got our atom, what's the atom's affinity for 1 electron, i.e. how easily can it gain 1 electron? And then once we've formed the ion in the gas phase, how much energy is released when it either enters into a solution or it enters into a lattice structure. Okay, so let's now apply this to F2, Cl2, Br2 and I2. Okay, so move that onto there. So how does this apply to F2, Cl2, Br2 and I2? And these are the key points to note. Okay, because there is a general trend as you go down group 7, because generally as atoms get bigger, the halogen bond, or the covalent bond, sorry, in the halogen molecule should get weaker, okay, because the bond gets longer, therefore it's going to be a little bit weaker. However, there is an anomaly to this, okay. The FF bond is actually weaker than the CL-CL bond, which is stronger than the BR-BR bond, which is stronger than the II bond, okay. Something to note here, that the FF bond is weaker due to the 3 non-bonding electron pairs on each F atom of the FF bond, okay. So these 3 non-bonding pairs are very, very close together. That's got 3 non-bonding pairs, that's got 3 non-bonding pairs, and because that bond is short, the 3 non-bonding pairs there and the 3 non-bonding pairs there repel each other, which actually makes that bond really quite weak. Okay, so I've said that here. The neighbouring lone pairs repel each other, making the FF bond unexpectedly weak. Okay, right, let's have a look now at the electron affinity for the different halogens. Well, the electron affinity does not vary greatly from one halogen to another, so that really doesn't affect the oxidizing power of the halogens. And then finally, we've got to ask ourselves the question, which one releases the most energy when it enters into a solution or into a crystal lattice. Okay, so the F- ion, being the smallest, has the most to gain from being hydrated or from entering into a crystal. Okay, so therefore we can conclude, that F2 is a stronger oxidizing agent than Cl2, which is a stronger oxidizing agent than Br2, which is a stronger oxidizing agent than I2. So F2 is a stronger oxidizing agent than Cl2, which has stronger oxidizing power than Br2, which has stronger oxidizing power than I2. Okay, the next thing you need to do then at A level is you need to know an experiment that demonstrates this. Okay, so it's the same experiment that we did at GCSE. Okay, so now we need to know an experiment that demonstrates this lowering of oxidizing power as we go down the group. Okay, the experiment that does this is the reaction of a halogen with salts of other halogens. So there's my halogen, Cl2, reacts with sodium bromide. That is a salt of the bromide halogen, and because the chlorine is more reactive than the bromine, okay, it will displace it, so we end up with sodium chloride and Br2. Okay, so ionically, Cl2 aqueous plus 2Br minus aqueous goes to 2Cl minus aqueous plus Br2 aqueous. Okay, because the Br2 is produced here, what would we see in the reaction? The result would be the formation of a yellowy brown solution. Okay, and that's due to the presence of the aqueous Br2. Okay, so this is recapping really on GCSE. Remember that a more reactive halogen will displace a less reactive halogen from its compound, so therefore Cl2 will displace Br minus aqueous and I minus aqueous, whereas Br2 will displace only I minus aqueous. Okay, and now all we're doing is we're linking the oxidizing power of the halogens with these displacement reactions. Okay, so halogens that have greater oxidizing power or are stronger oxidizing agents, it's the same thing, okay, will displace halogens from the compound which would have less, which would be less strongly oxidizing. Okay, something worth noting here is that we never do these experiments with fluorine, with F2, because it's far too dangerous and because of its high reactivity. Right, so in summary then, F2 has greater oxidizing power than Cl2, which has greater oxidizing power than Br2, which has greater oxidizing power than I2, and this can be demonstrated through halogen displacement reactions. Okay, and I've got a few little tables of results here. We'll just have a quick look at these. Okay, there we go. That's the first one here. So the reactions of Cl2 aqueous with Br minus and I minus aqueous. Okay, so Cl2 plus my Br minus, Cl2 plus my Br minus, you get Cl minus and you get your Br2 produced. The Br2 being produced would cause a yellowy brown solution being produced. In this next experiment here, Cl2 reacting with I minus, so Cl2 reacting with I minus would result in I2 being produced, which is a brown solution. Okay, the next one here. Okay, so now I'm reacting Br2 with Cl minus and I minus. Well, Br2 is less strongly oxidizing than Cl2, so it doesn't displace it, so there's no change in that reaction there. Okay, but Br2 is more reactive, i.e. a stronger oxidizing agent than iodine, so it does displace the I minus from a salt of the iodide salt. Okay, so Br2 plus I minus makes 2Br minus plus I2. The I2 forms a brown solution. And then finally, there we are. Okay, the reactions of I2 with Cl minus and Br minus, you can see there that there is no reaction. I2, because it's the weakest oxidizing agent, it is the least reactive of the halogens. Okay, so that therefore it can't displace Cl minus ions or Br minus ions from salts of those halogens. Okay, thank you for watching, that's it for today. I hope that's been helpful, but don't forget to like and subscribe and click on our bell notification to stay fully updated.